This problem, and see, we're going in backwards order here. This problem is going to occur before the one that we just did, which is the empirical formula where we had to find it from the experimental data. So it's no accident that it's that way on the actual test. This is good practice. It's going to set the stage for the actual problem. And this is almost a trivial exercise, but that brings home what the point about the empirical formula being the simplest whole number ratio within any of these. And so what am I going to look for here to find the empirical formula? What's the mathematical expression for it? The something something something. The what? The lowest common denominator. Exactly. And because a formula is not going to contain any fractions in it. And the reason for that being is because I can't cut a molecule in half. I can't have a half of an oxygen atom. It'd be a different element. Okay? So it has to be some sort of whole number ratio of elements. So all I have to do is look for the lowest common denominator. Well, okay, anybody have trouble seeing what's the lowest common denominator in the first one? 6 and 6. What's the lowest common denominator? 6. So it's going to be, the empirical formula is going to be CH. And you'll have a periodic table at your disposal, but I'm going to go off from rounded numbers that I have off the top of my head. And where I get into trouble here, I might with boron and chlorine. I'll have to think about it. But carbon has roughly 12 grams per mole, 12.011 if you're looking at the periodic table. And hydrogen is going to be around 1.0079, roughly around 1 gram per mole. So that'd be 12 plus 13. So E, F, W. So that's the empirical formula, and the EFW would be around what? 12 and 1, around 13 grams per mole. And that 13 almost looks like a B, so try to write clearly. Okay. And this was, I misprinted that. That's supposed to be a 2 there, isn't it? Yes. Okay. So I have C2H6O2. So again, what do I do? What's the lowest common denominator? 2. So it's going to be CH3O. I simply divide by 2. And there was a typo in the key where I put the 2 there. Okay, that was my bad. So please, if you haven't already done so, correct the key to that effect. And the empirical formula weight here, we're going to be 16 grams per mole for oxygen. So the empirical formula weight equals, and you can work it out on scratch paper, but all I'm going to want to see on the test, this will be adequate for this, the answer. So it's 12 plus 3 plus 16. That's okay. 9 and 2 is 11. 31 equals 31 grams per mole. Okay, wow, look at that. 13 and 31 sort of inverted. Now, this one, what's the lowest common denominator?
3.
Okay, so it's going to be, I divide everything by 3. It's N, B, H, 4. So that is assuming around 14 grams per mole for nitrogen. I believe it's 11 grams per mole for the boron. Anybody got a periodic table nearby? Is it what, 11? 11? 10.81, yeah, 11. So it's 14 plus on the scratch paper, 14 plus 11, and hydrogen's 1, so 1 times 4 is 4. So that's 9, 29 grams per mole. So EFW is 29 grams per mole. And the last one, what's the lowest common denominator?
2.
Say it like Lewis Black. 2. Okay, so divide both by 2. 2. And we get, okay, here, I'm using simplified numbers. Okay, chlorine 35 grams per mole. Boron, we just said it was 11. 35 times 2 is 70. 70. And 11 is, so EFW, 81 grams per mole. Okay? So that one, my point here is, this is gimme points on the test. You should all nail this one. Yes?
The answer key says like 70.
So the answer key on which one?
B.
On D?
Yeah, so 70.9.
Okay, so it would have been, that was a typo.
It was typo.
That was a definite typo. It would be 80.9, which was rounded off to 81. So 80.9, or, and you're going to have a periodic table.
Oh, yeah.
So that was a simple typo. Thank you for catching that. Would you do me a favor and remind me tomorrow?
Sure.
So I can make sure that everybody knows that, is aware of that? Okay. Any other questions before we go on to the next one? So that was fast. And like I say, these are give me points. That's a wrap on that one.